to Tennessee's at-home learning series for math. Today's lesson for all fifth graders out there, though all children are welcome to tune in. This lesson is the first in our series. My name is Miss Williamson, and I'm a fifth grade teacher in Tennessee schools. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. Today we will be reviewing making equivalent fractions. We will be using the strategy of creating an area model, using a number line, and numbers. Before we get started, to participate, you will need the student packet for lesson 1 or a paper, pencil, and something to write on. I will give you a minute to gather your supplies. Let's begin. I want you to write the word equivalent at the top of your paper. Take a few seconds of private think time and jot down what you think that word means. Did you say equal or having the same value? That's correct. That's what the word equivalent means. Today we'll be reviewing equivalent fractions or fractions that are equal. Follow along with me on your paper as we begin. First, I want you to draw a rectangle. Now, I want you to decompose the rectangle into 2 equal parts. Directly below the rectangle, I want you to draw a number line. Start your number line where our rectangle ends and end your number line where our rectangle, Start your number line where our rectangle begins, end your number line where our rectangle ends. Label these points 0, and let's write those above our number line, 0 and 1. Now my question for you is, where do you think half should be on our number line? The half goes directly in the middle. Let's review really quick some things we know about fractions. In a fraction, like the fraction 1/2, the numerator, or the top number, tells me how many pieces I have. And the denominator, or the bottom number, tells me how many pieces it takes to make a whole. So in this example, my whole has 2 pieces, or my number line has 2 pieces. And when I've traveled one of the 2 pieces, I have traveled half. Okay? Now let's keep that in mind as we continue working with equivalent fractions. Can we rename our 0 and our 1 with a denominator of 2? Take a moment and think about how you think we could do that. This right here is 0 out of 2 pieces, or 0 over 2. We've already stated that 1/2 is 1 out of 2, and so we can rewrite 1 as 2 over 2, or 2 out of 2. Now let's do this process again. This time, I want you to partition or divide your rectangle into 4 equal parts or quarters. In order to do that, we are going to have to cut each half in half. Now I want you to do a quick write on your paper. What do you notice about the size of the pieces now that we have cut them up? That's right. Hopefully you noticed that they got smaller. They got smaller because instead of 2 large pieces, we now have 4 smaller pieces. Let's think about that in terms of real life. If I have a cake and I cut it in half and I share it with 2 people, versus having a cake and cutting it in 4 and share it with 4 people, which size slice is going to be bigger? The one shared among 2. So let's see how we would write this on the number line. Well, just like we partitioned our rectangle, our number line is going to need to be partitioned into 4s. And once again, I am going to cut each half in half. So now we stated that before this was 0 out of 2. So what do you think these blank spots need to be labeled as? Go ahead and label those on your number line. Let's see how you do. Hopefully you said 1 out of 4 or 1/4 and 1, 2, 3 out of 4 or 3/4. Now we're going to do the same thing we did to begin with, where we try to rewrite our 0 and our 1, but this time we're also going to rewrite the half. Let's think about how would we rewrite those fractions instead of in terms of 2 pieces or halves, in terms of 4 pieces or 4ths. Well, now we have, this is 0 out of how many? Out of 4. So we would write that as 0/4. 1/2, where it previously was 1 out of 2, it is now 1, 2, 2 out of 4. And our last section was 2 out of 2, but now that we've partitioned it into 4s, it is now 4 out of 4. I want you to ask yourself something. Did we change the size of our number line? Did we change the size of our rectangle? No, we didn't. We didn't change the size of anything. They are the same. So I want you to think for the moment. What do you think could be said about these numbers? What could be said about 0, 0/2, and 0/4? What conclusion can be drawn about 1/2 and 2/4? What conclusion can we draw about 2/2 and 4/4? Hopefully you said those are equivalent. They have the same value. So even though these look different, they represent the same amount. For this next section, I'm going to give you a task. I want you to solve that task independently first, and then we will go over together. Are you ready? Your task is to partition your rectangle one more time. This time, you're going to partition it into 8s. Task, partition into 8s. Did you take your 4ths and cut each 4th in half so that you now have 8 pieces? 1, 2, 3, 4, 5, 6, 7, 8, or we would say they have been cut into 8s. Does your rectangle look like this? Now I want you to do the same thing, except I want you to partition the number line. Did you cut your number line, each section, in half? So that instead of 4 pieces in the whole, we now have 8 pieces. Now I want you to label. I want you to label your number line into 8s. Do it. Hopefully that gave you enough time. All right, let's review. We have 0 out of 8, which we would label with the value of 0/8. Then we have 1 out of 8, 2 out of 8, 3 out of 8, 4 out of 8, 5 out of 8, 6 out of 8, 7 out of 8, and 8 out of 8. Does your number line look like this? Now, what do we call these fractions? What do I call those fractions? What could I say about 1/2 and 2/4 and 4/8? Write your answer on your paper. Did you say that they were equivalent or equal? That's correct. They are equivalent. Your next task is to list all the fractions you notice on the number line that are equivalent. Take a moment and do that yourself. Check yourself. Did you find them all? Did you say 0 was equivalent to 0/2, 0/4, and 0/8? What about 1/4 is equivalent to 2/8? 3/4 is equivalent to 6/8. And last, 1/2 is equivalent to 2/2, 4/4, and 8/8. Now I want you to study that list of equivalent fractions we created. Do you see any patterns? Jot down any patterns you see. Did you notice that in every example, the numerator and the denominator were both multiplied by 2? Let's check it. For 2 over 2, 1 times 2 is 2. 2 times 2 is 4. Let's do it again. Times 2 over 2. 2 times 2 is 4. 4 times 2 is 8. 0 times 2 is 0. 2 times 2 is 4. 0 times 2 is 0. 4 times 2 is 8. Check the rest of them and see if multiplying by 2 works. Three times 2 is 6. 4 times 2 is 8. It does work. When we multiply the numerator and the denominator both by 2, we get an equivalent fraction. But where does the 2 come from? Well, let's look. Remember when we originally started and we partitioned our halves in half, and then we partitioned our fourths in half. Each time that gave us 2 more pieces. That's where the 2 comes from. Now your next task. I'm going to erase my board while you do this. I want you to draw a model for the fraction 2/3. Go. Did you draw a rectangle? and partition it into 3 equal pieces. Remember, we were representing 2/3, which means that 2 of our 3 pieces needs to be shaded in. Now I want you to take a moment and do it with a number line. Go. Remember, our number line is going to start with a 0 and end with a 1. In between our hole, we partition it into 3 equal pieces. The first line would be worth 1/3 or 1 out of the 3 pieces, and the second line would be worth 2/3 or 2 out of the 3 pieces. And I'm going to draw a little dot above the number line at 2/3 to represent that number. Now, I want you to either use the rectangle or the number line to find an equivalent fractions for 2/3. Go. If you use the rectangle, you may have partitioned each section into 2. So now instead of thirds, we have what? We have 6. So 2/3 is equivalent to 1, 2, 3, 4, 4, 6. If you use the number line, you may have done something similar. You may have partitioned each of your sections and realize now they're not thirds, they are 6. So we would have had 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So both ways we determine that 2/3 and 4/6 are equivalent. Now remember, we talked about another way. We said before that I could take 2/3 and multiply the numerator and the denominator by 2 to create an equivalent fraction. Let's try it. Did you get 4/6? So far we know that all 3 methods gave us the same answer. But my question to you is, do you think only the number 2 will work? I want you to jot down on your paper a yes or a no, because we're going to see if your prediction is right. This time, you're going to start with the number 1/2. Can you model the number 1/2? My rectangle needs to be decomposed in half, and I would shade in how many? 1. 1 out of the 2. That represents 1/2. But this time, instead of using the number 2, let's try 5. Let's see if 5 works. So what that 2 meant, remember, was that we cut each piece into 2. This time, if I'm using 5, that means I'm going to cut each piece into 5. So let's do that. 1, 2, 3, 4. You'll notice I only made 4 cuts, but it gave me 5 pieces. I always tell my students 1 less cut than the number of pieces. 1, 2, 3, 4. So now, did I change the amount that was shaded in? No, I didn't. The value stayed the same, but I did make my pieces smaller. So instead of 1 out of 2 pieces shaded in, I now have 5 out of 10 pieces. So I could say that 1/2 is equivalent to 5/10. Now let's check this other method. If I multiply the numerator by 5, I get 5. If I multiply the denominator by 5, I get 10. Does it work? It sure does. Let's try another one. This time I want you to model the number 2/3. Go. How many pieces did you partition your rectangle into? 3, 1, 2, and my pieces are not equal, so I'm going to try that again. 1, 2, 3 pieces. And how many of those would we shade in to represent 2/3? 2 out of the 3. Very good. 2 out of the 3. So remember, we're testing if numbers other than 2 multiplied by the numerator and the denominator create equivalent fractions. This time, we're going to test the number 4. So let's see. If I did 2/3, numerator times 4, denominator times 4, that would give me 8/12. Remember before, the 2 told me how many pieces we were cutting it into. So let's take this piece and cut it into 4. 1, 2, 3 cuts, 4 pieces. 1, 2, 3 cuts, 4 pieces. 1, 2, 3 cuts. I didn't change the amount that was shaded in. I changed the size of the pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8. 8/12. 2/3 is equivalent to 8/12. So does the method work? It does work. We can multiply the numerator and the denominator by the same number to create an equivalent fraction. The reason that works is because 5/5 and 4/4 are both equal to 1. Think about it. Before, every time when we got to the end of our number line, remember when we had 2 out of 2, 4 out of 4, 8 out of 8, all of those were equivalent to 1. Anytime you have a number over itself, it's equal to 1. And anything times 1 stays the same. So to create an equivalent fraction, you can multiply the numerator and the denominator by the same number. So we've learned 3 different methods for creating equivalent fractions today. We've used a rectangle, we've used a number line, and we used multiplication. Before we close today, I want you to try one more problem. I want you to use whatever method you feel most comfortable with. You're going to take a moment to do that independently, and then we are going to go over it for you to check yourself. I want you to find an equivalent fraction for 4/5, but I want you to use the number 3. 4/5 using the number 3. Go. Some of you may have used the rectangle method. You may have decomposed it into fifths, or 5 equal parts, and shaded in 4 of those. 1, 2, 3, 4. Some of you may have used the number line and also cut that number line into fifths, showing that 4/5 is here. Since we were using the number 3, we know that each part needs to be cut into 3. So 1, 2, 3. So now, instead of 5 pieces, we have 15 pieces. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 15 shaded in. If you use the number line, you would have done something similar. You would have cut each of those into 3 equal pieces, and you also would have recognized that you would have traveled 12 out of the 15 spaces, or 12/15. Now let's check that last strategy. Using 3, can we multiply the top and the bottom by 3/3, which is equivalent to 1, and get 12/15. All 3 methods work. So today we have worked to create equivalent fraction by using one of these three methods. You sure did a great job. After the video, you will have some problems to complete on your own. Good luck and do your best. Tomorrow we will talk about how to add and subtract fractions using what we have learned today. If you have the packet, those practice problems for independent work are in the packet. If you don't, jot down these problems for independent practice. Finding three equivalent fractions for 3/4, 5/7, and 2/12. Let me restate that independent practice. You're going to find three equivalent fractions for each of these. Boys and girls, I've enjoyed doing some mathematics with you today. Thank you for inviting me into your home, and I look forward to seeing you in our next lesson at Tennessee's At Home Learning Now. Bye!
The value parents place on reading makes a big difference in a child's reading and language development. You don't have to be a teacher or a great reader to create and nurture a love of reading in your child. It's beyond words on a page. It's about using stories to engage your child in the world around them. Start early because language development begins at birth. Exposing children to books early enriches their daily lives and builds strong thinkers. Just having books in the home, no matter your comfort level in reading aloud, can help a child grow to love reading and learning. Let your baby touch, feel, and even chew on the books.
Bah, said Gregory unhappily. Let me see your unhappy face.
Ask your child questions about the book and experiences the characters are having. Use the pictures to spark meaningful, engaging conversation, relating pictures to things in the child's day-to-day routine. Share the joy of books by bringing the story to life. Read with enthusiasm and energy in any language. Try using different voices for different characters.
Is that we're all here together?
Make up a funny story using the pictures, or act out characters and sounds animals make.
Hey.
Encourage your child to copy you and make his or her own noises.
That's good.
And most of all, reading with children and exposing them to books from the moment they're born instills an everlasting love of reading and learning that they'll have for the rest of their lives.